Next, page number 4, write the polynomial function with rational coefficients in standard form with those zeros. This is going to be kind of a tough one because if negative 1 plus 2i is a solution, so is negative 1 minus 2i. And if negative root 5 is a solution, so is root 5. So this is certainly going to be a quartic polynomial. Remember, it's always x minus solution, so it's x minus my first solution, the one they gave me. Then it's x minus the other conjugate solution, 1 minus 2i. And then I've got two more to write in here, x minus negative root 5 and x minus the positive root 5. Let's make that smaller print there. Okay, so those are all the things I have to multiply together because I want to get it into this standard form up here. Okay, I'm going to do the simple ones first. That's going to be x plus root 5 times x minus root 5. For those of you who still like to think in terms of FOIL, that is a FOIL problem, but you're just distributing x and then distributing root 5. So distributing the x squared minus x root 5, distributing root 5, you get positive x root 5. Root 5 times root 5, one's negative, so the product's negative, and root 5 times root 5 is just a 5. So the ones in red there give me x squared minus 5 when I multiply them. Okay, now we got to do these big pairs. So I've got x, distributing this negative flips all their signs, plus 1 minus 2i. Distributing that negative flips their signs, x plus 1 plus 2i. And now I distribute the x, then I'll distribute the 1, and then finally the 2i. So here goes x. I get x squared plus 2ix. Next I'll do the 1. I get x, I get 1, I get 2i. And lastly I'll do the negative 2i. I get negative 2ix minus 2i minus 4i squared. Minus 4i squared comes from negative 2 times positive 2 and I times I. Now we'll clean this all up a tad bit. There's only one x squared term. There he is. There's an x and an x. It's two x's. Then I've got a 2ix and a negative 2ix. They cancel. I've got a 2i and a negative 2i. They cancel. Finally, 1 and negative 4i squared is actually plus 4. Remember, I squared equals negative 1. So I end up, when I multiplied those two big trinomials, essentially, x squared plus 2x plus 5, and now I've got to take that times the x squared minus 5. For most of you, that's going to be a relatively simple process if you can get to that point. Okay. Final solution, it looks like that I come up with, and you can check this and ask if you've don't get this in class, or don't have this when you come to class. I ended up with x to the 4th plus 2x cubed minus 10x minus 25. So that would be our final answer. That is a quartic, because of the 4th degree polynomial. Even though it didn't ask for you to name it, we should still be able to. Problem 5. Determine the zeros and the multiplicity. 5a, the beautiful thing is it's already factored. Okay, we're looking for a 0, so we're basically asking the question, what makes 2x plus 5 times x minus 3, and I'm going to write it twice because it is squared, equal to 0. The way we answer that, since these things are all multiplied together, so we just ask what makes each one of these equal to 0. Because if any of the factors equals 0, the product equals 0. Okay. Quickly solving gives us x is negative 5 halves, and the other two give us 3. Now we usually don't write 3 and then comma 3 again. What we say is that's negative 5/3 is one answer, and then 3 is an answer with a multiplicity of 2, because it happened twice. 5b, again, it's in factored form, which is great. We don't have to do any work. We should see from the last problem that when we had that x was that x minus 3 squared, it gave us multiplicity of 2. And so these exponents on factors cause multiplicity. The first factor, what would make x 0? 0 would. Multiplicity of 2. Happens twice because it's squared. What makes x minus 2 0? If x is 2. It happens twice. Multiplicity of 2. What makes x plus 7 equal 0? Negative 7 does. It happens 3 times. Multiplicity of 3. And we're done. Those are the things that make the original equation equal 0. Alright, 6a, we've got 5x times x squared minus 16 equals 0. This is also in factored form. 5x, what makes it equal 0? There's one answer. X squared minus 16 equals 0. There's a couple ways to solve it. I'm going to go ahead and solve it by factoring. And then these can each be set equal to 0. And I solve those. X is 4, x is negative 4. One answer, two answers, three answers. Okay. Moving on to B. B is not in factored form, so we're going to have to work at it a little bit. Here's problem B, written a little bit bigger. First thing I do when I want to check to see if I can factor is I make sure it's equal to 0. It is. I check for a GCF. It has one. It's x squared. I check to see if I can factor this quadratic any further. And I can. And now I set each factor equal to 0. Notice that exponent causing multiplicity. Okay. What makes x plus 2 equal 0? Negative 2. What makes x minus 3 equal 0? 3. Was an x to the fourth equation. I ended up with 4 answers. 0, negative 2, and 3, but 0 counts twice. And finally, moving on to problem C here. There we go. I just jumped to the next page. Problem C, I've got x to the fourth minus 8x cubed plus 16x squared equals 0. Looks like GCF is x squared. I'm going to have to finish this later on, but I'm thinking I can factor it. Maybe I can get it all done. X and x, 4 and 4, negative, negative, 0, multiplicity of 2, 4, and 4. So I would put 4 multiplicity of 2 as well. Okay, again, I found all 4 answers.